Good morning. Welcome back to the second part for the network models. In the previous class, we discussed about the network models as a basic for the OSI reference model. And right now we go for in-depth of OSI model and what are the layers inside that OSI model and what happens at every layer. Okay, fine. Yeah, coming to the network models, in the last previous class, you have seen whatever the data we are forwarding through the network, every piece of information passes through the different layers here, different layers. So among that, we have discussed the first one. It's an OSI reference model. Just we recall the OSI reference model here. Remember that this is a reference model. The name itself indicating OSI reference model. It's only the just of reference, and based upon that, this OSI reference model, we built an TCP/IP model. So right now we are using the TCP/IP model in the real case. So this OSI isn't just only for the reference model here. So just we go with all the layers inside the OSI reference model, and after the completion of these all layers and its responsibilities, we go for the TCP/IP model. Just we recall, the first two layer is an physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. So we discussed that the first three layers, the bottom three layers work for, or the bottom three layers or network support layers, and the top three layers are user support layers. And the transport layer is a bridge between these two groups. It's a user support group and network support group. Why we name it a user support group and network support group means, the user support group means the three layers or helps to the user, because we are naming it as an user support layer, and the maximum of these three layers are built by softwares only. Any software applications like Android is a software application, and any Word is a software application, Excel. So built upon these three, with these types of applications. And coming to the bottom three layers, this one group we name it as a network support layers. Why we name it as a network support layers means these three layers are a combination of network devices and same as softwares also. What are the network devices means? Like routers, hubs, switches, and repeaters. These are some devices which we use inside the network. These are some hardware devices. So to work all these devices, we need some sort of operating system also. So the bottom three layers is a combination of hardware and software. Yeah. So we go for every layer by layer right now. Just I start by the topmost layer. There is an application layer. There is an easy to understand for the persons when I can start with an application layer. Just I go with an application layer. Start with an application layer. Yeah. First, the application layer responsibility is it's responsible for providing the service to the users. Users nothing but I'm the user. I'm using one application like Gmail application in my system. How this Gmail application was opened to the user. So to open this Gmail application, this application layer is responsible for this process. I'm opening the Gmail application and I'm entering my mail ID, my password, and then same as I'm attaching some content to transfer to the recipient. So what is happening means this Gmail application was opened with help of this application layer. So I said that this application is responsible for the users. Yeah. So in this application layer, we are seeing some services, and same as we name it as in some mechanisms also and some properties also. These are some services like X.400 and X.500 and FTAM. FTAM nothing but file transfer access management. File transfer access management, to transfer the file and to access the file. All these FTAM management helps us to transfer the file to any from any application, and same as to access the file from through any application. These mechanism will be help us. There's an FTAM, file transfer management. And what about X.500? It's a directory service to create any directories, to open any directories, to store any data into the directories, All these processes and all these responsibilities are handled by X.500 mechanism. X.500 mechanism in the application layer. And X.400 is a message handling service. So I want to send the message. So this X.500 will be invoked at the backend, and it helps to send that message. And same as I want to access the message from other person. So these X.500, X.400 will be helpers at the backend. So these are some mechanisms which makes very easy to access the applications to the user, and same as to send the messages, to receive the messages, and to create the directories and everything. So that will be helped by the application layer. The application layer responsibility is to provide the services to the user, So this is the main responsibility for the application layer. This is the main responsibility of the application layer. And these are some mechanisms, X.400, X.500 and FTAM. And coming to the position of application layer, just see the position. At the top of the application layer, we are using the application. There is a user. And on the top of that application layer, we are using the user. And the bottom of the application layer, there is a presentation layer. So just an example, I'm opening the Gmail application and I'm entering the content there, and I'm attaching the content there. So to open the Gmail application layer is helping for me. So whatever the content I attach to the application layer, and I'm pressing the submit, and that's nothing but I'm adding a recipient, I'm pressing the submit. That message goes to the next layer, there is a presentation layer. So what happened in the presentation layer? The presentation layer is responsible for translation, compression and encryption. Same thing, I'm attaching the message at the application layer, and that message comes to the presentation layer. Here the presentation layer is doing the translation. Whatever the content I am forwarding, if suppose I am forwarding the content which was not understandable by the recipient, that will be translated to into its own language, or whatever the content I am sending, that will be in the format of text format. So the text format is not understandable by the machines, so that will be translated into the binary form. This binary form is not happens at this one, just as in sake I'm giving. Translation means this binary form is not happens at the presentation layer. So it will be completely translate from one language to another language. So there is one type of mechanism here. And compression. So I'm sending in 2 GB of data through the mail, but the 2 GB of data is very hard to transfer through the network. So what I'm doing here means, what this presentation layer will do here means, it compresses to the 1 GB of data. It compresses to the 1 GB of data. So 1 GB of data is easy to transfer by the network when you can compare to the 2 GB of data. So and same thing, encryption. So I'm hiding my original content. Encryption is in process. It's nothing but hiding original content from others. It's nothing but security purpose. It's a security purpose. So to do the encryption, I'm using so many types of mechanisms or algorithms like AES, DES, and RSA. We have seen these type of names in the previous class. So encryption is a mechanism where we do some process, nothing but hiding the original content from others. So these are the mechanisms: translation, encryption, and compression. Translation nothing but translating from one method to another method, or from one form to another form. And encryption nothing but I'm encrypting my original content to make some security. And compression, I am doing some process where the huge amount of data is compressed to small amount of data. It's an easy to transfer through the network. When I am having a minimum amount of data, it's an easy to transfer through the network. So this is a responsibility of presentation layer. When the data receives to the presentation layer, the presentation layer does these processes. And after the completion of all these mechanisms, the presentation layer is going to be add one header. So what is that header means? If suppose I am sending an packet, so in the application layer, I open the Gmail and I add the source address and I add the destination address and I add some content here. So the packet was reached to the next presentation layer. When the packet receives to the presentation layer having some processes there that performs on our original content. It's like translation, encryption, and compression. It does all the mechanisms on that. And after the completion of process, when the data receive going to the below of presentation layer, the presentation layer is going to be add an header here. Header to our original content. Header. What the header consisting of means, if suppose I did encryption mechanism in the presentation layer. So what type of algorithm I'm using? Type of algorithm I'm using? AES, or maybe I use AES or DES. So if suppose I use the AES, I will mention AES algorithm where I use for the encryption. So I'm giving some information for the next purpose. So I'm giving AES. By the help of AES, I have done the encryption. So I mentioned the AES algorithm in the header format. So at every layer, the layer is adding its own header and it's sending to the next layer below of it. So on same process, the application layer is also adding its header. The header consisting of some information, what the process you have been done in the application layer. If suppose I am sending an Gmail that belongs to message handling service, so I am going to mention x.400 there. x.400. So after adding a header, it sends to the next presentation layer. When the complete data receives to the presentation layer do some mechanisms and do some process on the data there. And after the completion of that, it adds some header there. And it fills some information into the header. And next, all the process was over at the presentation layer. Next, it sends to the next layer below of it. What is the next layer below of it? That one is an session layer. See here. There we are adding a header. This is an sending part and this is an receiving part. So we are going to the session layer. So what data will receive to the session layer means, so my original content plus headers of two layers, that is this header belongs to the presentation layer and this header belongs to the application layer. Just I am writing presentation layer header, application layer header, and this is a source address and this is a destination address, and this is my original content. So right now, this is a complete data which receives to the session layer. So when my data receives to the session layer is responsible for creating a dialog control and adding in synchronization points. So what is a dialog control and what is a synchronization points? See here, I am sending in 2 GB of data here. My original content is on 2 GB of data. I am dividing the 2 GB of data into some parts. It's an 500 MB and 500 MB and 500 MB and 500 MB. Like that, I divided into 4 parts. So after completion of every part, I am adding one synchronization point. Synchronization point. I mentioned why I will going to be mentioned what is the importance of synchronization point. At every 500 GB, at every 500 MB, I am adding one synchronization point. One synchronization point. What is the use of this synchronization point means? Just an example. Just analyze. If I'm going to be sent 2 GB of data through the mail, if suppose the mail was dropped in the network due to some reasons, the mail was not received to the receiver due to some reasons, what happened? The data was lost, and same as again I need to send 2 GB of data again to the receiver again and again. This is nothing but retransmission. I need to retransmit the 2 GB of data to the receiver. Same. When I do the retransmission, I am wasting time, and same as I am wasting resources. What is the resources here? Bandwidth is an resources. Bandwidth, it's nothing but internet. Bandwidth is the resources, and same as I'm creating some traffic inside the network because I'm retransmitting my content. I'm retransmitting my content. So to overcome these type of issues, I'm placing synchronization points at everywhere. Synchronization points at everywhere. So what happens when I add in synchronization points means, what happened when I send an asynchronization points means, if suppose this is an first slot, second slot, third slot, and fourth slot. When the 2 slots was received to the receiver, from the 3rd slot onwards, I'm not receiving the content. So right now, I will retransmit only the 3rd slot and 4th slot, not all the slots, not all the content here. So by doing this one, I am reducing the time occupation in the network, and same as I am reducing the resources usage, that is an bandwidth usage. If I send 2 GB of data, I need bandwidth of 200 Mbps, 20 Mbps. But when I can send 1 GB of data, I need only the 10 Mbps of data to send 1 GB of data. So I'm reducing the resources here, and same as I'm reducing the time occupancy inside the network. Time occupancy inside the network. So these are usage, these are very helpful of adding in synchronization points in our data here. So there is an synchronization points. And what about the dialog control? Dialog control nothing but creating link between two systems. Creating link between two systems. So that is nothing dialog control. So link nothing but making a path between sender and receiver. So there is a dialog control. So we are initiating that I want to communicate from A to B system. So this session layer is going to be create a path from A to B. The path may be connectionless or connection oriented. That is a part of that. So we can see in the next coming layer that is an connectionless or connection oriented. So the main responsibility of session layer is this one. When the data receives from the physical layer, when the data receives from the presentation layer, the session layer is going to be do this process. So right now the session layer is also going to be add header for this one. This is a session layer header, this is an presentation layer header, and this is an application layer header, and this is a source address, destination address, and our original content. And we are encapsulating and sending to the next layer below of it. Encapsulating nothing but encapsulation. Encapsulation nothing but we are making an it's like a packet. Encapsulate, we have seen the capsules, right? It's like in tablets, capsules. We are hiding the original content. Encapsulation is nothing but hiding of an original content and sending to the next layer below of it. Same thing, we are doing the encapsulation at every layer and we are sending next to the layer below of it. So right now our complete data goes to the next layer, that is an transport layer. See here, the transport layer. The transport layer is responsible for what is the main responsibility of transport layer? The transport layer is responsible for delivery of message from one process to another process. It was very important. So just I go with an basic architecture here. See here, this is an A system and this is an B system. In the A system, the system is running 3 applications, and same thing, the B system is also running 3 applications. So this is an Gmail, it's an Instagram, it's an yahoo.com, So right now I am communicating with the Gmail. The message need to be received to the Gmail or Yahoo. Defaultly the message need to be go for the Gmail. Go for the Gmail application. It won't go for the Yahoo application. So remember that when we say the data communication was effective means when the data communication was effective means when my data goes to the destination system exactly, or when my data goes to the recipient exactly. So observe here, to make this communication we need 3 different types of addresses. One is an IP address. We see these addresses in the next content. Just I'm giving this IP address and MAC address and port address. We need 3 addresses, very important in the network. With the help of these 3 addresses only, we are communicating, we are sending the data. The IP addresses are helpful to reach my message to the system only, to the device only, but my message need to be go to the application. So to reach to the application, the port address helps for that. So observe that the network layer is responsible for host to host. The transport layer is responsible for process to process delivery. So I am communicating from Gmail to the Gmail. So my message need to be go to the Gmail application only. So to reach to the Gmail application, the transport layer is responsible. To reach my message to the Gmail application, I need to add port address. It's an 16-bit size. It's an 16-bit of length. I need to add an port address. The IP address is an 32-bit of length. Remember the word 32-bit of length. The MAC address is an 48-bit of length. IP address is an 32-bit of length. Port address is an 16-bit of length, and MAC address is an 48-bit of length. So these are the 3 important addresses we need to use inside the networks. Clear? So the transport layer is responsible for process to process delivery. Remember the responsibility. So, and coming to the transport layer, we are forming and we are using some mechanisms here. See the mechanisms or mechanisms or properties we say. The first one is an source point addressing. We name the source point addressing as an port address. We already mentioned, to make process to process delivery, we need an port address. That's an 16-bit address. We are embedding this port address into the packet and sending. Next, segmentation and reassemble. Segmentation is nothing but dividing, and reassembling is nothing but we are making these segments into the same packet. I'm having large packet. It's an 1 GB of data, and I'm dividing this 1 GB of data into the 10 packets. It's an 1 MB, second MB, third MB, fourth MB, and fifth MB, and so on, and so on, and so on. So when I'm dividing 1 GB of data into the segments, for every segment I'm giving the number, that is an service number. Service number 1, 2, 3, 4, 5, 6, so on. Because of it's an easy to reassemble. Because of it's easy to reassemble. I'm segmenting. It's nothing but dividing here. So when I'm dividing, I'm giving the service numbers. These service numbers like 1, 2, 3, 4, 5. These service numbers helps us to reassemble at the receiving side. I'm segmenting here at the sender side, and I'm reassembling at the receiver side. How should we reassemble? How should we know that this is in first segment, this is in second segment, this is in third segment? It depends upon the service number. I am going to be reassemble that. And next one, connection control. Same thing. Connection control. This is also one type of mechanism. We need much more explanation about this connection control. We talk about this connection control and flow control and error control. These are very important mechanisms which you use in the network. Flow control and error control and connection control we talk about in the next coming classes or next coming videos. So these are all the responsibilities of the transport layer. When the data receives to the transport layer does this. It is going to be add an port address to the packet, and same thing it does segmentation and segmentation whatever the data receiving from the top layer, that is a session layer. And same thing, this transport layer is also adding a header. What the header consisting of here means, where we have been how we have been done the segmentation, and same as for the flow control and error control, we are having some mechanisms. What type of mechanism we are using for the flow control and error control, we can mention in the header, because that will be helpful for the receiving side, at the receiving side. So this is a representation of transport layer. Above transport layer there is a session layer, below the transport layer there is a network layer. And right now we are moving to the network layer. The network layer was very important in the network. What is the main responsibility of the network layer? The network layer is responsible for delivery of packets from source host to the destination host. See here, the network layer is responsible for source host to the destination host only. It delivers the packet. From source host to the destination host only. It's nothing but see here, this is a complete network. They are having 1, 2, 3 systems, and multiple switches there, and multiple transmission mediums. These are all the transmission mediums, and these pink colored one are the switches, and these are all the systems. So I want to communicate from A to D. A is in source and D is in destination. I want to communicate between A to D. So in the packet, what we add, as in source I'm going to be add A system, and as in destination system I'm going to be add D. Observe that I'm going to be add as in D. But this is the process where the network layer is responsible to send the packet from source host to the destination host. And it's having some mechanisms. They are having two mechanisms. One is a logical address and routing. So logical address and routing. Logical address is nothing but an IP address. When the packet receives to the network layer, the network layer is going to be add an IP address here. It's an source IP addresses and destination IP addresses we are adding at this layer. And routing nothing but is one type of mechanism where our packets are routed from one device to another device. To transfer from, see here, this is a source and this is a destination. Between the source and destination, there are many number of devices. So how my packet need to be go in this direction or in this direction? Here, the routers are going to be help us. It routes my packet to the destination system. It routes my packet to the destination system. So depends upon the routing table and depends upon the routing algorithms. Our packets are routing from source host to the destination host. There are many number of routing algorithms. It's like just I mentioned the names. Right now I'm not going to be discuss the routing algorithms. It's like shortest path routing algorithms and distance vector routing algorithms, distance vector routing algorithms, shortest path and distance vector, and link state routing algorithm. Link state routing algorithm. When we are discussing these routing algorithms, we'll talk about all these routing algorithms, link state routing algorithms. These are the main important, and there are many routing algorithms, but we use the distance vector and link state routing algorithms in maximum. So there are some different routing algorithms we discuss in the routing algorithms here. So thank you. We'll go for the next content.